Hello and welcome. A new case in binomial distribution, and that is how many tosses of a coin are needed so that the probability of getting at least one head is 87.5%. First of all, why should we solve this problem through binomial distribution? We need to find number of tosses, that is small n. That means number of trials are finite and fixed or countable. Number 2, in all trials, probability of getting head remains constant 1 by 2. Probability of not getting head remains constant 1 by 2. So, the binomial distribution is fit or suitable to this kind of cases. That's why we are going to solve this problem through binomial distribution. So, P equals to 1 by 2, that is P of head in each and every trial, and therefore Q is also 1 by 2, that is 1 minus 1 by 2. Now, what do we mean by probability of at least 1? That is P of R or X greater than or equal to 1. At least 1 means 1 or more, greater than or equal to 1. So the interpretation is P of R or X greater than or equal to 1 is 87.5%, means 0.875. Now we don't know the value of n. Okay, no problem. If we substitute all these things in binomial formula, that is P of R successive equals to NCR into P raised to R into Q raised to N minus R. What exactly P of R greater than or equal to 1 is? P of R greater than or equal to 1 is equal to 1 minus P of none. P of at least 1 is always 1 minus P of none. So 1 minus P of none is 0.875. That means 1 minus 0.875 equals to P of none, and therefore P of none equals to 0.125. This is the key point. Now let us substitute all these things. P of none equals to 0.125. What do you mean by P of none? NC0 into half raised to 0 into half raised to n minus 0 is n equals to 0.125. NC0 is 1 into half raised to 0 is 1 into half means 0.5. In both the sides we are going to take now the values in decimal form. 0.5 raised to n equals to 0.125. This is 0.5 raised to n equals to 0.125 ultimately. Now we are going to use trial and error method because that is the easiest. Let us take n and 0.5 raised to n. N can never be 0 or negative, at least one trial should be there. So n can take value 1. If n takes value 1, 0.5 raised to 1 will be 0.5. If n takes value 2, 0.5 raised to 2 will be 0.25. If n takes value 3, 0.5 raised to 3 will be 0.125. Yes. So 0.5 raised to n equals to 0.125 is possible only if n is 3. So 3 tosses of a coin are needed so that the probability of at least one head is 87.5%. But the key point is, why should we use the binomial distribution? N is countable, fixed or finite. Probability of success failure remains constant in each and every trials, and all the trials are independent, blah blah blah. All the conditions of binomial distribution are satisfied the data. Number 2, this is the key point, probability of at least 1 means probability of 1 minus probability of 0 or none. Simplify the data in this format. Only if you can arrive at this stage, you can solve this problem at any time. That's it. Thank you very much.